Sikorsky Aircraft, a subsidiary of Lockheed Martin, unveiled one of the most significant transformations in military rotorcraft history: the conversion of the UH-60L Black Hawk helicopter into a fully autonomous, pilotless platform known as the S-70 UAS U-Hawk. The project marks a dramatic shift from traditional crewed helicopters to large uncrewed aerial systems capable of executing complex missions without direct human intervention. The U-Hawk combines decades of proven Black Hawk reliability with cutting-edge autonomy and fly-by-wire technology, positioning it as a major step toward unmanned battlefield logistics and support operations. In this video, Defense Updates analyzes how uncrewed S-70 UAS U-Hawk is a riveting concept. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The Black Hawk has served as the backbone of U.S. Army rotary aviation since its introduction in 1979. Known for its versatility, durability, and global service record, it has been used for troop transport, cargo lift, medical evacuation, and assault missions. Its proven design and logistics ecosystem make it an ideal candidate for autonomous conversion. Rather than developing a new airframe from scratch, Sikorsky's engineers leverage the existing UH-60L platform, integrating autonomy and advanced control systems while retaining compatibility with established maintenance infrastructure. This approach promises faster deployment, lower costs, and smoother integration into existing fleets. Transforming a crewed Black Hawk into the autonomous U-Hawk required extensive re-engineering. The cockpit, pilot controls, and mechanical linkages were completely removed, replaced by a new third-generation fly-by-wire system that allows for digital flight control. Without a cockpit, the forward fuselage was redesigned with a pair of actuated clamshell doors and a fold-down loading ramp, enabling rapid roll-on and roll-off cargo loading. This reconfiguration increased the internal cargo capacity by nearly 25% compared to the original design, allowing the aircraft to transport larger payloads or even small vehicles. These structural changes demanded careful management of weight balance, aerodynamics, and center of gravity adjustments, ensuring that performance and safety margins were maintained despite the absence of human pilots. At the core of the U-Hawk's capability lies Sikorsky's Matrix Autonomy Suite, a modular software and sensor system that enables the helicopter to conduct all phases of flight without human input. Matrix allows the aircraft to start its engines, take off, navigate to its destination, avoid obstacles, land, and shut down entirely on its own. The autonomy system is supported by redundant flight computers, inertial navigation units, terrain-following sensors, and advanced radar and LiDAR arrays. The system also includes vision sensors for real-time situational awareness and collision avoidance. Ground operators can control or monitor missions through a tablet interface, which allows even minimally trained personnel to input mission objectives, after which the aircraft plans and executes the route autonomously. The inclusion of full fly-by-wire control also improves stability and response times, ensuring precise handling in low visibility or degraded conditions. The U-Hawk's design not only enhances autonomy, but also significantly expands its payload and mission flexibility. With the cockpit eliminated, the aircraft's cabin can carry larger or more numerous payloads, including standard joint modular intermodal containers, resupply pods, or missile launch canisters. It can also accommodate roll-on vehicles such as unmanned ground vehicles, allowing for fully autonomous air-ground logistics operations. Externally, the U-Hawk retains the same 9,000-pound, 4,080-kilogram sling load capacity as the manned UH-60, enabling it to transport heavy cargo beneath the airframe. Furthermore, Sikorsky envisions the U-Hawk as a multi-role platform capable of carrying and launching small aerial drones or air-launched effects. Depending on configuration, the aircraft could deploy up to several dozen drones for reconnaissance, decoy operations, or electronic warfare. The aircraft's self-deployment range is expected to exceed 1,700 miles, 2,735 kilometers, with endurance reaching up to 14 hours, offering unprecedented flexibility for unmanned operations deep into contested territory. Converting a manned helicopter into a fully autonomous system presented several engineering challenges. Removing the cockpit altered the airframe's balance and weight distribution, requiring adjustments to fuel placement and internal ballast. The newly designed clamshell nose and ramp system had to maintain aerodynamic efficiency and structural integrity under flight loads. Replacing mechanical flight controls with digital fly-by-wire demanded a redundant and fail-safe architecture, capable of maintaining stability even if one or more subsystems failed. The avionics had to integrate autonomy processors, environmental sensors, and mission management computers, all while ensuring electromagnetic compatibility with legacy helicopter systems. Cooling and power requirements for these new systems were also carefully addressed, as continuous autonomous operations generate far greater computational loads than human-piloted missions. However, challenges remain before full operational deployment. Autonomous flight in contested airspace introduces serious vulnerabilities to electronic warfare, GPS jamming, and cyber threats. Maintaining control and navigation integrity in such conditions will require advanced sensor fusion, secure data links, and fail-safe fallback modes. From an operational perspective, the U-Hawk promises a dramatic transformation in how rotary wing aircraft are employed. Removing the human crew eliminates risk to pilots in high-threat environments, such as contested supply corridors or urban combat zones. Autonomous logistics flights could sustain forward-deployed units without exposing personnel to anti-aircraft or electronic warfare threats. Without the need for pilot rest cycles, unmanned sorties can be scheduled continuously, potentially doubling daily operational output. The U-Hawk can also serve as an unmanned launch platform for drone swarms or resupply pods, creating an entirely new layer of flexibility in distributed warfare. These capabilities align closely with the Pentagon's broader shift toward autonomous and attritable systems, vehicles that can be produced at lower cost and used in greater numbers without risking human lives. According to Sikorsky, the U-Hawk prototype moved from concept to production in roughly 10 months, a remarkably short development cycle. The company plans to begin flight testing in 2026, with operational evaluation likely to follow in the next year. Though not yet part of an official acquisition program, early interest from the U.S. Army suggests potential use cases ranging from cargo resupply to launch platforms for autonomous drones. As nations pursue future vertical lift initiatives and expand unmanned capabilities, the U-Hawk could serve as a vital bridge between current helicopter fleets and the fully autonomous systems of the future. The S-70 UAS U-Hawk thus represents more than an experimental conversion. It is a technological and doctrinal milestone. By blending a proven legacy airframe with state-of-the-art autonomy, it demonstrates how militaries can modernize existing fleets without waiting for entirely new designs. The aircraft embodies the shift toward distributed, risk-tolerant, and machine-driven warfare, where uncrewed systems perform the dangerous work of logistics, reconnaissance, and battlefield support. While full integration will take time, the U-Hawk stands as a compelling preview of the next era in rotary wing aviation, where helicopters no longer need pilots to dominate the skies.